Encapsulation, abstraction, and polymorphism. The fundamental ideas of object oriented programming. Although inheritance is also a part of this group, but we have kept that for a different set of discussion because that is a more elaborate thing to discuss on. So let's explore these three foundational ideas of OOPS programming languages out there one by one. The first one is encapsulation. So, encapsulation, as we know, is the ability of an object to hide its data and methods from the rest of the world. And it is the fundamental principle of object oriented programming. In Java, a class encapsulates the field which hold the state of an object and the methods which define the actions of the object. So the question comes, how do we do it? We do it with the help of the access level modifiers that determine whether a class can use a particular field or can invoke a particular method or not. So there are basically four types of access levels that are available in Java: public, protected. When we say no modifier, that means package, and private. So public, as we all know, is open to all. You can access a particular field or method if it is defined as a public from any part of the world, from any other class, from any other package, from whenever you want. But you need a very good reason to make something public. Then we have protected, which we use in the case of inheritance. No modifier means package level access, that or if something is available at the package level, then it is naturally available at the class level. And when you say private, then it is the opposite of all three. It means you can only access something only from the inside the class, not even from the another class of the same package, not from the subclass and not from anywhere. But there's a way around to fix this. If you have private fields and you want to provide the access to those private fields, then you can use the public getter and setter methods to expose them to the outside entities. So encapsulation does not need any such demonstration to see how it works. We do it all the time in our programming. Now let's move to the another important concept, and which is abstraction. Abstraction is the process of hiding certain details and showing only essential information to the user. And it can be achieved either with abstract classes or interfaces. So you must be wondering that here also we are hiding certain thing and only exposing certain specific things to the user. But this is the not same as the modifiers. It is a more elaborate thing. It's about providing a whole concept as a template to the user and hiding its implementation detail, and or we can say let the user to decide how to implement that concept in its implementation part. So there are two ways to do this. Either you create a class with the abstract keyword, provide a template of the concept there, and let the subclass to decide how to implement it. Or if you want a more general purpose template, then you can use the interfaces. Another important concept of object oriented programming is polymorphism. It is the ability to have many different forms. We can say more generally that the concept of polymorphism is often expressed by the phrase one interface, multiple methods. That means it is possible to design a generic interface to a group of related activities. Polymorphism helps reduce complexity by allowing the same interface to be used to specify a general class of action. It is the compiler's job to select the specific action, like in the case of function overloading or in the case of constructor overloading, as it applies to each situation. So, what kind of parameters you are passing, on the basis of that, the compiler decides which one to call. You, the programmer, don't need to do this selection manually. You need to only remember and utilize this general interface. When we talk about polymorphism, it can be of two form, either at the compile time or at the runtime. And you must have heard the word static polymorphism and dynamic polymorphism, which is related to this. Here, an interesting concept also comes, which is called the virtual method invocation. So, in Java virtual machine, when the Java virtual machine calls the appropriate method for the object that is referred to it in each variable, that is called virtual method invocation. It does not call the method that is defined by the variable's type. This behavior is this behavior is decided by the method which is passed to it, or by the reference which is passed to it. So basically, polymorphism is supported by inheritance. When we do inheritance, then we do method overriding. And when we do method overriding, then we use the idea of virtual method invocation. So to use polymorphism, to see how polymorphism actually works, you need inheritance in your system. And when we will go to the inheritance part, then we will come back again to the polymorphism to see how it looks like in the functioning mode.